Okay, good afternoon, everyone. Thank you for coming all the way down here to the very furthest possible corner of the building, I think. Hopefully everybody reached their step goal today. Good work. All right, so I'm Travis Wright. This is Ronnie Chatterjee. We're PMs on the SQL Server engineering team. I'm really excited to come and talk to you today about the future of SQL Server and what we've announced this week about SQL Server in big data. Did you guys all hear the announcement? I assume everybody's here because they heard that, not just because they're randomly interested in this, right? So this has been a project we've been working on for about a year so far, and it's been kind of this top secret skunkworks thing. But in many ways, what we've done here is we're really stretching the boundaries of like what it means for like SQL Server as a name, right? And I think we're just going to kind of open up sort of a lot of possibilities for everybody today as we kind of talk through what we've done here and how this all works. So this will actually be a two-part session. Today we'll kind of have more of an overview session with lots of demos. And tomorrow morning at 9 a.m., we're going to start with a deeper dive session on all this that we're doing around SQL Server and big data. And some of the other PMs on our team, like UC and Mahalo, will be leading that session tomorrow morning. So please come for that one as well. Hopefully it's somewhere closer than this one. Okay, it's the same room. You can just sleep here if you want. It's fine. If you don't want to walk all the way back to your hotel, you can just stay here. All right, so let's get started. Just to set some context, as we talk to customers, I think people are starting to feel a little overwhelmed by all the data that's being generated. It's getting pretty crazy. And something like 80% of the world's data right now has been generated in just the last 2 years. That's pretty mind-boggling. And not only is this data being generated at an ever faster rate, but the types of data that we're dealing with are changing rapidly as well. And so really, as we try to take on some of these challenges from getting insights out of all this data that we have, the barriers to getting that insights is becoming increasingly difficult because of the complexity of our systems. The amount of data that we have is just growing crazy. And we have so many different types of data. We have data in lots of different types of databases and so on. And so it's kind of interesting. Every year we do this survey of a few hundred customers. And what we try to do is we try to ask questions about what technology they're using and how they are using that to sort of advance their companies in comparison to others. And then we look at some of the success metrics about these companies, like what's their operating margin, how profitable are they, that sort of thing. And we try to derive some insights about how these successful companies do things differently when it comes to technology. And 3 things popped out to us in the survey over the last year or two. The first is that a lot of these companies that are being very successful in the market right now are doing their data integration without using ETL. They're taking approaches where they are putting their data into a central data store like a data lake, and then accessing that data from different patterns, right? So maybe you want to access it through SQL. Maybe you want to use a Spark job against it, that kind of thing. And so people are trying to centralize their data into these data lakes. And we also see that the companies that are the most successful are the ones that are embracing using machine learning and AI to drive predictive analytics. And so as we look at these trends and what is making for successful companies, and those are the ones that are going to last the longest and drive things forward the most, we want to take a look at how SQL Server can help them do those things even better. And so today what we're going to talk about is how SQL Server 2019, with these big data clusters we're going to talk about, is going to help you do 3 things. First is integrate all of your data, regardless of where it's at and regardless of what type of data it is. We're going to help you manage all of your data easily and securely at the scale and with good performance. And we're going to help you analyze all of your data. And you'll see here this repeated pattern of all data. And you'll see what I mean by that as we go through this presentation. And to do that, we want to give you a consistent management experience and tooling experience, which you'll see in our demos today. So let's start with integrating all of your data. So IDC did a survey, it was like 2016, and they asked people about their data movement and what kind of impact that might have on them. And one of the things that popped out to me was, wow, 75% of these companies that are responding to the surveys say that the timeliness of their data is impacting their business opportunities because they're moving it through all these ETL pipelines. Probably some of you probably have a spaghetti of ETL pipelines going every which way inside of your data architecture today. And data movement, while it has its place as a data integration approach, has some problems. First of all, it increases the cost in terms of duplication of storage. It costs money to build and maintain those ETL jobs. It takes time to move that data through your ETL pipeline. It takes time for you to build the code that actually will move the data before you can actually start using it in your report, for example. So when your executive comes to you and says, hey, I need this report tomorrow, you're like, oh, sorry, it's going to take 2 months just to build the ETL pipeline and get the schema figured out, right? And then actually move the data there before you can even start building the report. Moving your data around, creating copies of it, increases your security risk as well, because now you have multiple copies of your data. That increases your attack surface area. And you have potentially that data sitting in different database systems that are secured in different ways. And keeping a common security architecture across multiple different types of databases is pretty challenging. Lastly, as you're moving all that data through all of your ETL pipelines, you can introduce data quality issues. And for companies that have compliance regulations like GDPR, it can be really problematic when you have multiple copies of this data all over the place and your users come and ask you to delete that data. And then you sort of ask yourself, like, I have no idea how many databases that's in. Sorry, that's not a good answer. And so what we want to do is we want to give people an alternative, in addition to data movement, of using data virtualization. And data virtualization helps address some of these problems by leaving the data in place in whatever system it's already in, but yet be able to query it from SQL Server using tools that you're already familiar with. Whether it's an application framework or Power BI or some other analytics tool, everybody knows how to talk to SQL Server. And now let's make it easy for you to, through SQL Server, go get data from other places and not make a copy of it, but actually query it from the source at the time the query is issued to SQL Server. And do it in a fast way. And so we'll talk through how we do that. So in SQL Server 2016, we introduced the Polybase feature. You guys probably are familiar with that, right? And Polybase enabled you to query SQL Server and hit an external table that was defined over HDFS in a Cloudera or Hortonworks cluster. And when you issue that query to SQL Server will go out and either run a MapReduce job in the Hadoop cluster and get the data back, or remotely stream the data from HDFS and bring it back through SQL Server back to whatever query was asking for that data. And that's a data virtualization technique. But it only worked with Cloudera and Hortonworks HDFS. In SQL Server 2019, we're taking that same Polybase technology and improving it and expanding upon it to add additional connectors to more data sources. Oracle, Teradata, other SQL servers, MongoDB, and any sort of ODBC compliant data source. You want to hook up to MySQL or Postgres, go for it. You want to hook up to a cloud service like Azure SQL DB or DW, by all means. Cosmos DB, no problem. We tested that out just the other day. Using the MongoDB connector, we were able to connect to Cosmos DB through the Mongo API. OK, cool. Now we can go get data from all over the place, bring it back in through SQL Server using external tables. So let's take a look at an example of doing this, where we'll create an external table using the Azure Data Studio external table wizard. So we want to make this as simple as possible. How many people tried to create an external table using Polybase and T-SQL before? It's not exactly simple, right? So we want to make it simple for you, OK? So what we're going to do is we're just going to come in here, right-click on this database inside of Azure Data Studio, and we're going to go to Create External Table. Oh, hang on. I got to pop out of the presentation. Thank you. OK, so this is the external table wizard. I just right-clicked on the database and said Create External Table. And I'm going to create it in the sales database inside of my SQL Server. I'm going to choose the Oracle type here. And over time, we'll add additional types for the other ones, like MongoDB, Teradata, HDFS, and generic ODBC. And I just click Next. I'm going to skip over this next screen here where it asks me to create a database master key, because I've already done that. And now we just give this table a name. I'm going to call this Oracle Inventory. And we're going to go to this server here that I've already got set up conveniently. And put in our database name. And we're going to create a database scope credential at the same time. And now you can see that over here, we're going to go and browse to the schema that exists in that Oracle database in real time here. And we're going to choose the table that we want to synchronize over. And we can even see, hang on, there we go. We can even see the schema of that table, and we can do column mapping if we wanted to. So if we want to change the names of the columns, we want to change the name of the table that's defined in SQL Server, et cetera, we can do that. And now we create that external table. And we can go back into our database here. Oh, lost my connection. Hang on. OK, go into our database, sales, tables. Here's our Oracle inventory table we just created. And we'll just do a select top 1,000 over that. And just like any other table inside a SQL Server, you just query it. You just select star from it. You can do column selection, all that kind of stuff. You can do predicates and so on. And you can just go get that data from wherever it's at the time you issue the query to SQL Server. What do you guys think? Pretty cool? OK, so we actually demoed it this morning in the overview session. Some people go to that one where they saw using the data virtualization connector as an approach to migrate from Oracle to SQL Server. So you start out by creating an external table over Oracle using this data virt wizard here. And then you put all of your reporting and that kind of stuff on top of that external table. And then you just eventually move all the data over into an actual SQL Server table. And you just change the view that you're pointing to and go get that data out of the table that exists inside a SQL Server. So it's a way for you to kind of use this as an approach for data migration as well. OK, so that's how we are going to help you do data integration through data virtualization. Makes it easy for you to combine this data together. And because they're just tables inside of SQL Server, if you want to, you can even do joins of the data. So for example, you have an external table over Oracle. You have an external table over another SQL Server. You can actually join that data together. So now let's talk about managing all of your data. And for those people that have deployed a big data cluster, you know that it's a big task. And sometimes it's pretty challenging to actually go out there and deploy a big data cluster. So we want to make this easier for customers, not just to deploy a big data cluster, but to integrate together your relational and big data environments into a single integrated solution that is provided by and supported by Microsoft. So to do that, as you guys have heard the announcements this week, we are actually putting Spark and HDFS and some other open source big data components like Knox and Ranger in the box with SQL Server. These open source technologies will become a part of SQL Server. And if you think about it, SQL Server has always been a scale-up database engine. If you want to manage more data, you want to have faster queries, you go to one of your favorite OEMs and you buy a bigger server, right? And so now what we're going to do is we're going to give you this big data architecture in a way where you can run it on a more flexible hardware architecture that can scale out elastically by leveraging the Kubernetes container orchestrator. So Kubernetes is a way for you to provision a Kubernetes cluster of available compute resources. And when you deploy a SQL Server big data cluster onto that Kubernetes, as you'll see here in a minute, it's a very automated, very simple process to provision all those containers out onto Kubernetes and upgrade it very easily. So I just wanted to share with you some of the reactions we had to the news that was announced this week. We had really great press coverage on it, lots of great tweets from various people, maybe some of you here in the audience. It's pretty exciting to see the reaction to this. That was my favorite one there, the holy S one at the top. Good stuff. So we're really excited about this, and we hope you guys are too. So what do you guys think? Is this pretty cool? Put Spark and HDFS in the box? OK. So let's take a look at what this architecture actually looks like. So in order to let's just start at the bottom. The foundation is your storage layer. And so in this architecture, we'll have a very interesting and unique architecture. On every HDFS data node deployed in the SQL Server 2019 Big Data Cluster, you will have an HDFS data node and co-located with it a SQL Server instance and a Spark engine. And you can scale this out. Each of these is deployed together in a Kubernetes pod, and you can scale it out. You can have as many pods as you want. So as you need more storage capacity, you need more compute capacity, you can scale that out as much as you like and as much as you have a Kubernetes architecture underlying that to support that capacity demand. Now, the nice thing about going on Kubernetes is it's very fast to deploy and easy to deploy, which we'll see here in a minute. It also makes it easy for us to upgrade it. We'll have an orchestrated, automated, rolling upgrade of the whole thing. And it makes it easy for you to scale it up. You want more storage, you just deploy more pods. You need more compute, you deploy more pods. So I want to show you how easy it is to deploy a SQL Server 2019 big data cluster. And we partnered with our friends over at HPE. They let us borrow some of their Elastic platform for analytics hardware. And we've set it up so that we can actually do a demo of this for you here. So I'm going to pivot over to an RDP session I have into that environment. And I want to show you what this looks like to deploy a SQL Server 2019 big data cluster. OK, so here I have a Windows desktop, but I've got some SSH windows going into the environment. I'm going to use this tool called MS-SQL-CTL. It's a Python-based command line utility. You can run it on Windows, Mac, or Linux. I happen to be running it on a Linux terminal here, which I'm SSH'd into through PuTTY. And to deploy a SQL Server big data cluster, you might think this might take a long time, and it might be hard, but it's not. I just run that. MS-SQL-CTL, create cluster, give it a name, off it goes. OK? So now what you can see is, as these pods start to come up, we can keep an eye on the progress here. So first, the controller pod comes up, and that controls the orchestration of rolling out everything else. And you can kind of keep an eye on this over time over here. We'll see, like right now, we have the number of pods distributed across these 16 nodes of the Elastic Platform for Analytics cluster from HPE. And you'll see those pods start to come up inside of there. Now, this takes a few minutes. So if we have time, I'll come back towards the end of the session, and we'll take a look at how that's going. But that's it. Very simple. Don't want to make it hard. OK, now I want to talk a little bit more about the architecture. So the way this works is that you deploy your, what we call a storage pool of these pods that contain Spark, SQL, and HDFS all together. And then you can issue a query to a SQL Server master instance. And this master instance, in the near future here, will also be able to be an always-on availability group deployed on Kubernetes. We just announced the preview of that capability in general this week. And that will be available inside of the SQL Server 2019 big data cluster here pretty soon. So then you get read scale capacity and always-on availability group level of high availability inside of a SQL Server 2019 big data cluster. And the whole thing is running on top of Kubernetes, and you have persistent storage underlying that to make sure that all of your data is preserved, even if a pod for some reason crashes, or even if an entire Kubernetes node goes down. All of your data will be persisted into that persistent storage. And you can recover that by having the pod be automatically reprovisioned to another Kubernetes node, because that's what Kubernetes does, right? It's an orchestrator of deploying these pods. OK, so now I want to do another demo, which is creating an external table over HDFS. And in this example, I'm going to create a table that goes over the HDFS inside of a SQL Server 2019 big data cluster. So to do that, I'm just going to start here, do a new query. And we're going to create an external table. Now, if you guys remember, creating an external table inside of SQL Server 2016 and 17 over HDFS was pretty involved. You had to do all this stuff to specify how to connect to Cloudera and Hortonworks, that kind of thing. In the case of HDFS being in the box inside of a SQL Server 2019 big data cluster, you don't have to mess around with all of that. It's already there and built in. And all you have to do is say that your data source is the SQL storage pool. And that's referring to the HDFS that's built in inside of a big data cluster. And then you just give us a path to wherever that data resides. Tell us what type of file it is. Give us the column that you want to read the data into. And that's it. And now, oops, too far. Don't want to drop the table. And now we can run this query and actually go get this data out of HDFS. And this is millions of rows of data sitting inside of a CSV file down in HDFS. And we're going to reach down and get that data back, put some structure around it, and return it back as a SQL Server result set like you'd expect to find from querying any other type of table, except in this case, it's an external table that we created over HDFS. I really hope this works. There we go. OK, so there we go. We're reaching down. And the way this works is that we're actually reaching down to the SQL Server instances that are co-located there next to the data nodes in HDFS and issuing that query to them and having them get the data and return it back to us. Now, as we saw there, the query performance was OK, but we can make it faster. All right, we still have a year or more left to do the tuning on this thing before we release it. But there's another technology we want to bring to bear here to make it easy and fast to do this. And that is we're going to introduce a caching tier as part of this architecture. And so what you'll be able to do is provision what we call a data pool. And a data pool is a set of SQL Server instances deployed as containers on top of this Kubernetes cluster. And you can point to an external table, basically. When you create an external table, whether it's over Oracle or Teradata or the HDFS inside of the big data cluster or HDFS in Cloudera, it doesn't matter. And you can say, I want you to basically cache this data inside of this data pool. And you can point to a data pool. And what will happen is we'll go and we'll query that data from the source, automatically partition it and spread it across n number of SQL Server instances that exist in that data pool, and store it inside of MDF files across all those SQL Server instances. And then we're going to automatically put column store on top of it to improve performance by caching everything in memory. And then when we go to do a query over that data, the local filtering and aggregations will happen in parallel in each SQL Server instance, in parallel, right? And then we return the data back up to the master instance. So we parallelize out the execution of the filters and local aggregations. The other nice thing about a data pool is that you can combine data from multiple data sources together into one data pool. So if I had, for example, an Oracle database and a MongoDB and an HDFS, I can create external tables over all of those, cache them all to the same data pool, and then I can create joins across that data that are processed in the data pool. OK, now there's another use case for data pools. Let's say you have a data feed, which is more of like an append-only type of data feed, like an IoT data stream. In this pattern, you can say, OK, I've got this IoT data coming in. I might want to write it to HDFS. That's a pretty common pattern. But maybe I want to also be able to query over it really fast using the SQL Server engine. I can take that data, partition it, and spread it across n number of SQL Server instances inside of a data pool. And from there, I can then query the data where I have the pattern of doing the local filters and aggregations across all the SQL Server instances in parallel. So this like takes SQL Server to a different dimension, right? Like where SQL Server used to be a scale-up system, it can now scale out with these data pools for these append-only types of data ingestion patterns. So this should really boost the performance of your queries, whether you're using the data pools for data virtualization or for persistent storage for a streaming data pool. We want to make the performance even faster. So the way that we're going to do that is we're going to introduce the concept of a compute pool. And a compute pool is very similar to a Polybase scale-out group, where you have multiple SQL Server instances deployed as a compute pool. And then the compute pool, what it does is each SQL Server instance will pull in a partition of the data from the external data source, like Oracle, let's say. And then as those SQL Server instances receive that partition of the data, they then work together to do cross-partition aggregations and shuffling of the data. So we can parallelize and sort of separate out the query for that type of a query off to some separate compute resources from the SQL Server master instance. And this will really boost performance when you're doing data virtualization queries, whether it's over Oracle or HDFS. But we don't want to stop there. Let's put compute pools over these other external data sources. Then let's combine data pools and compute pools. So as you get data from external data sources or these IoT data streams, and you're ingesting that data into the data pools, and then you go to do a query over it, the local aggregations and filtering are going to happen in parallel across n number of SQL Server instances that you have in your data pool. And then the compute pool is going to receive all that data, and the compute pool is going to do the cross-partition aggregations and shuffling of the data before it sends it back up to the master instance. Right? So it's sort of mind-blowing to think about the compute power that's available here. OK, now, we also want to make the management of this very simple. So we're going to provide some tooling that you can use, which we've seen here a little bit so far. Azure Data Studio is the tool that you can use to manage the whole environment. You can connect to SQL. You can browse your tables there. You can run your queries, do all that kind of stuff. And you can connect to the Spark endpoint and submit Spark jobs. You can browse your HDFS files and so on. One tool, the only one I know of like this, where you can do everything in one tool. Secondly, we're going to provide a management service as part of this. So the management service will provision a bunch of agents that run in every pod in the entire architecture. And those agents will collect monitoring data and all of the logs back to InfluxDB and Elasticsearch that are provisioned as part of it. And you can use that then through an admin portal that comes in the box. Browser-based portal. You can view all the monitoring dashboards there. You can do log analytics using Kibana. And the admin portal allows you to provision additional compute pools or data pools. It helps you manage the security around it. And the management service also takes care of the services that you need for doing things like automated backup, automatically provisioning high availability for the always-on availability group on the master instance, automatically helping you do rolling upgrades. And all of these kinds of things, the monitoring, everything, it all just comes in the box with the big data cluster. And no matter where you deploy this big data cluster, whether it's on a Kubernetes cluster on premises, or you deploy it on a managed Kubernetes service in Azure like AKS, or you deploy it on something like OpenShift on premises or OpenShift on Azure, or even a third-party cloud like those other guys, it doesn't matter. Wherever you have Kubernetes, you can deploy a SQL Server 2019 big data cluster, and the management experience comes with it. And it's consistent, regardless of where you deploy it. And so this is a hybrid technology that you can deploy wherever you want. Oh, I forgot to advance the slide. Should have said something. All right. OK, now when it comes to security, security is super important. And it's hard to integrate security between your relational environment and your big data environment. But when you deploy a big data cluster, the security comes pre-integrated. And it's integrated not just between SQL and the big data part of it, but it's integrated with Active Directory. And further, where we can, we will do impersonation. So when you connect to a SQL Server master instance and we need to go out and get data from an Oracle, for example, we will impersonate the user going out to get that data when it connects to Oracle. So this architecture helps you simplify your big data, helps you deploy it all as one thing, helps you operate and manage it all as one thing, and it's all integrated together. Next, we want to talk about how to help you analyze all of your data. And analytics is an interesting thing, right? It's such a fast-moving and growing area. And everybody's trying to learn along with everybody else. And we want to try to make this as simple as possible. You know, if you were to listen to Satya Nadella, he'd say something like, we're trying to democratize AI. You know, something sort of visionary like that. And what that really comes down to is, like, let's make it simple for people to use it. So one of the things we want to do is we want to take the ML services, which we've built into the last 2 releases of SQL Server, and apply that at the top tier in that master instance. So I can have ML services up there. And now, not only can I train my models over the data that exists inside of SQL Server, but I can now feed data through those external tables easily into my model training. So I could create, for example, an external table over Oracle, and then do a select on that for my master instance, pull that data in, maybe pull in some data from HDFS through another external table, join it together, and then just feed that into my R or Python script inside of the SQL Server master instance and produce my model right there inside of SQL Server. And once I've produced the model, let's not go put it someplace else necessarily. We can just put it right back inside of SQL Server as a blob inside of a table in SQL Server. And then let's operationalize it right there inside of SQL Server as well. So So I can just take a stored procedure, for example, and somebody's going to call that stored procedure, and they're going to provide me some input parameters. I'm going to take those input parameters, and I'm going to score it against that model using either R or Python, or the new native T-SQL predict function that we provide out of the box that can do 1 million predictions per second. And in this pattern, your machine learning, model training, scoring, operationalization, everything never leaves the boundary of SQL Server. And we try to make it easy for you to do this by you just do it inside of SQL Server. Now, if you have Spark in the box, some new interesting possibilities open up. Lots of data scientists prefer to use Spark. They prefer to use languages like Scala and Python and R and all this, right? And so let's now give them Spark. But let's give them Spark that's integrated into an enterprise-ready security boundary of SQL Server and open up some new possibilities for them where they can use Azure Data Studio to browse the data that might exist in SQL, or they can use notebooks, which we'll see here in a minute, to interact with the data that exists in HDFS. And let's open up some possibilities here. So for example, I can use Data Studio to query the master instance. I can use Spark to go and run jobs inside of the storage pool. And I can also query external data sources. So now you can imagine a pattern where, like for example, a Spark job comes in. The Spark job connects to the SQL Server master instance, which has some external tables in it that are defined over Oracle and Teradata. And the Spark job now has access to all that data through SQL Server. Right? So you can easily integrate all your data together through SQL Server and feed it into your machine learning model training. Your data scientists don't need to have the data exported out of those systems and put on their laptops. That's bad. That's bad. I won't name names, but I went to go visit my bank, a big one, and I was very appalled by the security pattern they had around what they were trying to do, right? So do not export your data out of your proprietary, very secure systems onto people's laptops and things like that to do analytics, right? Keep that data inside of SQL Server and have that data be queryable through SQL Server. Never leave that boundary. And you can use Spark ML to do your model training as well. So we really have the entire pipeline of machine learning covered for you by the big data cluster. We can ingest data in through Spark streaming or through SQL Server integration services. We can store that data inside of the data pools, inside of the master instance, or in HDFS. We can then do data preparation using Spark. We can use either Spark ML and all the libraries that are available through that, like TensorFlow and Caffe and so on. Or we can use machine learning services built into SQL Server, where we can use R and Python there to train our models. And once we have those models produced, we can operationalize them either inside of the SQL Server master instance, or pretty soon we're going to show you how you can actually take those models, run it through a toolkit we'll provide, and we will automatically wrap that model with a Swagger-based REST API, and then automatically provision it for you on top of the Kubernetes cluster. And now you can generate a client-side API like this for any programming language you want, and all of your applications can now hit that REST API and operationalize your model that way. So let's say you had a model that was like an image classification model. Your application developers can now submit an image to that REST API, and they'll get back a response like, oh, that's a puppy, oh, that's a dog, that's a cat, whatever. And it just makes it that easy to operationalize these models for people. And we can deploy it in a scalable architecture where if you need to bump up the number of REST API containers that are providing that model as a service, no problem. It's Kubernetes. You click a button, and it provisions a couple more pods for you. Very powerful. So if you think about the 4 V's of big data and AI, SQL Server Big Data Clusters really help you do these 4 things. The first is that we're going to improve the velocity of your data. You're not going to have to ETL around your data as often anymore. You're going to go get the data from the source at the time that you need the query, or you need the data. And you're going to be able to do that fast because you have this scale-out compute architecture and the caching in the data pools. And you can use Spark, which is a distributed compute engine, to do all of your data preparation. If you're running all of your data through a single ETL server to do all of your preparation of your data and moving it around, you're doing it in a way which is, by definition, bottlenecked by the capacity of that one server. With Spark, you can do everything in a parallel compute environment that can execute it across a scalable number of compute nodes. We're also going to increase the variety of your data by giving you access to lots of different types of data, whether it's structured or unstructured. You've got graph inside of SQL Server now. You've got JSON and XML inside of there. And you can also go get data from other data sources like Oracle or Teradata and bring that all together into one place and combine it together. And so you have a greater variety of data, which will improve the quality of your machine learning as well. We're also going to improve the veracity of your data by ensuring that there's not any data quality issues that are introduced as part of your ETL pipelines and like constantly transforming that data as it goes from one machine to another and so on. And we're going to give you real-time access to that data. Nobody wants to make business decisions based on data that was from yesterday. That doesn't make sense. We need that data right now. We need to be building machine learning models that are based on the data right now. And we're also going to give you access to a greater volume of data, whether that volume is represented by the scalable storage architecture of HDFS that you can scale up to petabytes of storage, or in the sense that you have access to a greater number of databases that you can bring in through data virtualization. Either way, you're increasing the total volume of data that you have available to your machine learning. Now, one very interesting thing that's in development right now is HDFS tiering. So a lot of people are adopting these data lakes. They have data lakes that are on premises. They have data lakes which are in the cloud. People have data lakes that are data lakes of data lakes. I call those data puddles. Our CTO says that was a boring marketing term. We should call it data lagoons. But that's the kind of thing that's happening now. And what we want to do is we want to make it easy for you to keep your data in one place, but be able to access it from another. So this is where HDFS tiering comes in. This is actually a technology that's recently been added to HDFS itself, and we're going to light up inside of a big data cluster. What it allows you to do is, like, let's say, for example, that you have chosen to use Azure Data Lake as your data lake, but you have an on-premise big data cluster as well, and you want your applications that are on-premises to have access to that big data lake. No problem. You can set up HDFS tiering between the two, and the files that exist in the data lake can be available to your HDFS that's on premises. And the files aren't actually stored there in the HDFS on premises. They're just like virtually represented there. And when you, from the point of view of a Spark application running inside of your on-premises big data cluster, they look like regular files. But when Spark or SQL goes to read it, HDFS will automatically go and get that file from the Azure Data Lake and materialize it in memory in that HDFS inside of your big data cluster on premises. And from that point forward, it's just another file. You can just read and write to it just like you normally would. And you can flip it around the other way. So maybe your files are stored on premises, but you want to tier it through Azure Data Lake and then be able to use Azure services like Azure Machine Learning, for example, to access that data that exists on premises. So now we want to show you a few more demos of some of these things where you can use Spark and HDFS together to do data preparation and machine learning. So let's connect up to this cluster I have here. Now, for demo purposes, this cluster happens to be running in Azure Kubernetes Service, because we wanted to show you how you could run this in Azure Kubernetes Service. But this could be an on-premises data center as well. It doesn't really matter. It's just Kubernetes. And in this environment here, I have HDFS. And this is where you can kind of browse your files. It's just like a file explorer. You can view all the files in your HDFS. You can download them. You can preview them. You can do interesting things with them. You can upload files. And this is the interesting thing here, is I have this mounts directory. And so this is a directory that is mounted on Azure Data Lake. And I can browse the files and folders that exist in Azure Data Lake underneath that mount point as though they were files and folders in my on-premises, or in this case, Azure AKS-based big data cluster. Sort of mind-blowing. Like, it's not actually there, but we are able to virtually represent that here. And I can just right-click on this and preview it, and it'll actually go get that file for me from Azure Data Lake like that. And I can actually see the file inside of here. But maybe that's not enough. Let's actually do some analytics against it. So this is our notebook experience here. This notebook experience is built on top of Jupyter as part of Azure Data Studio. And it has a familiar experience in the sense that you have these cells where you write code, whether it's Python or Scala or R, and you can execute each cell independently and get back the results from your query. And the results can optionally be stored inside of the notebook file itself to make it easy for you to share your analysis with other people by just simply sending them a file. So what we can do now is we can execute this cell. And what this cell does is it goes and reads this CSV file that actually happens to be an Azure Data Lake into a data frame, and then it shows us the content of that file. So now I'm using Spark. I'm reading a CSV file, but it's from Azure Data Lake. And now I want to create a Spark SQL table over the top of that. And now we can query it using traditional SQL syntax. And the scenario here that I'm doing is we've got a diabetes data set. This is a very common data set that's used for like machine learning demos. And the idea here is that we want to use machine learning to predict whether or not somebody will have diabetes based upon some of their attributes. You know, what's their age, what's their gender, what's their glucose level, and so on. And so this first SQL query that comes back, it shows us, you know, the insulin level of the people by age. And so maybe that's a good way for us to just, you know, visually look at this and see if there's any correlation. You can see people here that are kind of higher up in the age spectrum have a high level of insulin, but then so do some of these people down here that have been probably staying up too late eating donuts or something, right? So that's not a good way to do it. So let's use machine learning. So here we can use Spark to do a featureization of the data. And once we have the featureization defined here, you can see some of the different features that we have of our data. And now we can run it through an algorithm, like a k-means algorithm, to actually classify all this data. And then we can start to do some predictions based on that. And you can see this is just a very simple experience of like just running through these notebooks and getting the data back. You can look at it, and you can just run your code, right? So now let's do a prediction. Let's see if BMI, the body mass index, is a good predictor of whether or not somebody will have diabetes. And we can see here that the spread between, you know, the BMI of somebody that does have diabetes and somebody that does not is pretty big, 35 versus 31. So that's a fairly good indicator of that. Now we can see whether or not pregnancies is a good indicator of whether or not somebody will have diabetes or not. And not surprisingly, the number of pregnancies that somebody has is not a good predictor of whether they will have diabetes or not. Okay, so this is how we can bring the power of machine learning through all of the Spark libraries that are available to the data that exists inside of HDFS, whether it's the HDFS inside of SQL Server or inside of Azure Data Lake or even other HDFSs like a Cloudera or Hortonworks HDFS. All right, so now I want to turn it over to Ronnie to do a demo of data preparation using Spark.
Cool. Thank you, Travis. Good afternoon, everyone. So pretty mind-boggling, huh? So what Travis just demoed. So I'm going to show you some of the phases of data preparation. Now, data preparation is one of the important phases of the evolution of data as data flows through the various stages. And traditionally, data scientists spend a significant amount of their time preparing the data in a way which they can consume later on. So what we have done in our notebook experience within Azure Data Studio is we wanted to make the data scientists more empowered with the tools we have so that they get a data preparation package out of the box for them. And this data preparation package, which I'm going to show, is actually a package which has been developed by Microsoft Research. So here, I'm going to show a sample file here. It's called artist.txt. And if you can look at this file, you can see that they have field descriptions at the top. There is like white spaces in the top. There is some blank white lines. Then there is a pipe command here. And you can see that there is the structure of the data is not formatted pretty well. They have some currency code here. Now, as a regular data scientist, if I have to process this particular file, I would need to write complex regular expressions, exactly figure out how many lines to skip, exactly figure out where my white spaces are. And this can be very time-consuming at times, right? So what we did was, in our integrated notebook experience, which we have in Azure Data Studio, we have a package. And this package comes within the notebook experience itself. It's called the PROS Code Accelerator. The Code Accelerator, what it means is we are empowering data scientists to be more effective by generating code for them. A code which gets generated by looking at the sample of the file and making a guess of what the best optimization code would be in order for them to generate that file. So here I have this artist.txt file, and I am going to pass in that file name basically just to PROS. And let's see what happens. Here you go. So PROS, what it did was, PROS generated this particular line of code for me. It figured out the exact number, exactly what the delimiter was, exactly how many rows to skip, and generated this code for me. Now, as a data scientist, I can take this code and run, or even include it into my production quality code as well. So what I'm going to do is I'm going to copy paste this particular code. And then I am basically passing in the artist.txt file. So the data which was unstructured, completely had a lot of characters and a lot of blank spaces, finally, immediately got some structure to it. Now, one of the fine things is you might ask me that, OK, say I'm not a Python developer. I want to generate my code in PySpark, because we are doing Spark, and Spark gives us the flexibility of running distributed workloads much better, right? During the phases which Travis was saying, that is one of the main benefits of using Spark. So what I can do is I can comment this particular line here. And now I say, OK, generate code for me in PySpark context. Here I have PySpark context of the code which was generated from PROS. So PROS is giving the flexibility of generating code into multiple languages as well. Now, if I just take this particular line of code which was generated, and I have another notebook opened where I'm going to just run that particular cell. And this, as you can see, as Travis was mentioning, that we have multiple kernels we support in our notebooks. So when you're connected to this notebook experiences, you by default get connected to the PySpark kernel. This is the kernel which allows you to submit your Spark jobs. So basically, it's connected to this particular cluster. And now I'm going to just run this code. And this is also an AKS cluster we deployed. Getting a server error from. Should have worked. Let me just open up a new notebook here. We're running production code here, so that's OK. See for this one. I have to restart the Spark context here, so that takes a little while. So while this Spark application is running, let me also show you some of the examples which we have done in our integrated notebook experiences. So if you are a local Python developer, one of the things which data scientists do a lot is they install custom packages from TensorFlow, scikit-learn, Matplotlib. Now, what we have done is we also have an integrated manage packages option, which would allow data scientists to easily install custom packages. And OK, so this is a fine example. It's giving me an error saying that, OK, I need to install this particular packages here. So let's see. Come on.
Demo under pressure here.
Yeah. Try to copy this guy. Control C. V. Should have just done it. What's going on here?
Do you want to go onto the Spark Submit one, maybe?
Yeah.
Okay.
Probably just do. Okay. So so somehow the module pandas is not working, and I apologize for this demo mashup. But so basically, what it does is with this code, you would be able to submit this code against the cluster, and you would be able to load the exact same file from HDFS file as well. Now,
I think you just got the wrong copy paste, right? Because you have pandas running inside of Spark.
You just copy paste the wrong.
I think it was just a copy paste error. Yeah, copy that again.
I thought that it did.
Yeah, because you got pandas there. Pandas isn't inside of Spark, so there you go. Run that.
Let's see. Okay. Now we have the artist.txt here. Copy path.
Yep.
Okay. Come on, you can do it. Come on. Now you see some of the files which got generated from PySpark using the artist.txt file. Okay, so one of the things I would like to show in addition is, for example, say you want to submit a Spark job. And this is one of the things which is very common for data scientists to do against submitting Spark jobs against the cluster. So what we have is we have made it simple for data scientists to actually submit Spark jobs from the cluster directly. So I'll say a test ignite here. And then I'm going to copy over the path to where my jar file is. Now, this jar file can basically be files which you have pre-compiled in a different environment. Whether you are authoring your code in VS Code or in IntelliJ or in Eclipse, you have compiled a jar file. And now you want to submit this jar file against this particular cluster. So
it's on your Visual Studio Code.
yeah,
VS Code.
I won't risk copy pasting anymore.
You're gonna test your memory.
So as you can see, the Spark job has been submitted to this particular cluster. And what we basically did was we have integrated ourselves with, contributed back into the ecosystem. So here you could see the link to the Spark UI. So now if I switch and click, you could see that this Spark job was exactly submitted into this Spark job history server. And this also gives me some of the enhancements which we did on top of the existing Spark UI, which the community already has. This is the Spark application and job graph viewer. Now, if I actually play the job, it actually goes through the stages in which Spark actually submitted the job in. This gives me a representation of how much resources Spark is actually consuming as it's doing the distributed processing over this big data file. Thank you so much today.
All right. Thanks, Ryan.
Yeah.
Good job, man. Demo under fire. Well done, sir. OK, good. So that's just kind of a quick tour of some of the things you can do with Spark inside of your big data cluster. And really the idea here is to make it easy for you to manage your entire machine learning pipeline, from ingestion of the data through storing that data in various ways, being able to do the preparation tasks that we saw today, even using technology from Microsoft Research like Pros. And then you can train your models, store your models inside of SQL Server or HDFS, score against them, operationalize them all in one integrated platform. So if you just step back and look at what we announced around SQL Server 2019 Big Data Clusters, it's really three things. The first is a data virtualization capability that allows you to integrate your data from multiple data sources and not just simply query them, but query them with amazing performance because of the data pools caching it and the compute pools doing the cross-partition aggregation and shuffling of the data. Secondly, big data clusters integrate together SQL Server and Spark and HDFS as a single deployed solution that is provided by and supported by Microsoft. And lastly, it is a complete AI platform that allows you to do everything through your entire AI pipeline and integrate together all of the data through the data virtualization, this HDFS, and produce your analytics on top of all of that. In summary, it really drives your innovation. It allows you to integrate all that data, manage all of that data, and analyze all of that data. So where do we go from here? Like I mentioned, we've been working on this project for about a year. It is now in public preview. The SQL Server 2019 preview on Windows and Linux is completely open. Anybody can go get that. You just go download it or Docker pull and run a container, whatever you want to do. But the big data cluster part of SQL Server 2019 is currently something that you need to sign up for at this EAP, Early Adoption Program site. And we will gradually roll it out to customers as we go. And the reason for that is really just because we want to have a really close relationship with the customers that are actually deploying these big data clusters so that we can learn from them as we go here. Obviously, this is a huge leap forward in terms of what SQL Server can do. And the architecture is somewhat complex, and it involves things that people in the data space are still learning, like containers and Kubernetes. And SQL Server customers in general are not that familiar with Linux. And so there's a lot that we need to help customers through in this journey towards SQL Server and big data being combined together. So we want to help customers do that. And that's why we have this early adoption program where people can sign up. And we'll have PMs on the team like me and Ronnie that will be assigned to work with each of these customers to help you as you try to deploy this and start getting your hands wrapped around kind of this idea of a big data cluster and how you integrate it with your other systems like Oracle and maybe your existing Cloudera or Hortonworks clusters, for example. So please go and sign up if you're interested in this. And we'll be available. We have some of the other PMs up here in the front row to answer any questions you might have here after the session. And then please come back again tomorrow morning at 9 a.m. And we'll go another level deeper in terms of how this all works and really learn kind of the details of all of this. So thank you guys for coming out today.
Thank you all.
We really appreciate it.